Hello, protocols, packets, and programs. We're visiting one of the few natural preserves left for wild processes. Here amongst the user space, creatures like the North American reduced process roam free. However, a species of belligerent protective fauna also inhabits this region. These extended BPFs are fiercely territorial. When they hear the call of an unfamiliar animal, they investigate and prepare to defend their space. Let's watch. Which means this week we chat with Liz Rice about learning eBPF and how it benefits networking, observability, and security. In the news segment, Azure and the Big Bang, 3CX and the Smooth Operator, a game of code, a game of prompts, and more. Protect some wildlife and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
Imperva is the comprehensive digital security leader on a mission to help organizations protect their data and all paths to it. Only Imperva protects all digital experiences, from business logic to APIs, microservices, the data layer, and from vulnerable legacy environments to cloud-first organizations. With an integrated approach combining network, application, and data security, Imperva protects companies ranging from cloud-native startups to global multinationals with hybrid infrastructure. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva.
This is episode 235, recorded April 3rd, 2023. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Mike, good morning. Good to see you. Just want to let all listeners know really quickly, this episode might run a little bit long, might be a little buggy. We're going to rewrite ASW in Rust, so hang in there, stay with us.
I'm glad we've embraced the refactoring. Thank you, John. While you're waiting for us to refactor, you can save $100 on your RSA Conference 2023 full conference pass. RSA will take place April 24th through 27th in San Francisco and on demand. To register using our discount code, please visit securityweekly.com/RSA2023 and use the code 53UCyber. We hope to see you there. Also, B-Sides SF is the weekend before, so come early and attend both. Liz Rice is the Chief Open Source Officer at Isovalent. She sits on the CNCF governing board and on the board of Open UK. She was chair of the CNCF's Technical Oversight Committee in 2019 to 2022 and co-chair of KubeCon and Cloud Native Con in 2018. She's the author of Container Security and Learning eBPF. We'll see how many times we say that correctly this episode. She also has a wealth of software development, team, and product management experience from working on network protocols and distributed systems and in digital technology sectors such as VOD, music, and VoIP. She also makes music under the pseudonym Insider9, which I think is pretty awesome. Hello, Liz. Thank you for joining us.
Hi, what a great introduction. Thank you very much.
Well, it's because we have a great guest, and you are here to walk me back from the ledge, over the ledge, about all things eBPF. I'm not sure which way, because it's a really cool technology, but it seems a little bit intimidating to write and to debug as well. So that's what scares me, appeals to me about it. But before we get to me, let's talk about you. What brought you into the eBPF world in this, deep security space?
Yeah, so I actually remember precisely when I first heard about eBPF, because I saw Thomas Graf, who I now work with at Isovalent, but I saw him presenting the Cilium project at DockerCon. We were both speaking in the same track at DockerCon in 2017. And I remember him talking about Cilium and how it uses this eBPF technology. And I thought, that's pretty cool. I'm going to keep an eye on this. But at the time, nobody really was using kernels that had that level of support. It was still pretty cutting edge stuff in the kernel. But fast forward to today, and basically pretty much everybody is running a new enough kernel in production that they can take advantage of eBPF. So that's why you're starting to hear about it kind of everywhere.
And that's cool. And, I think one of the things is that why we want to hear about it everywhere. I touched on a little bit, just three words: networking, observability, security. But I think that's perhaps not compelling enough to convince someone that they should be using eBPF. So tell us a little bit about what are some of the use cases? What are some of the reasons, security or not for that matter, someone would want to adopt this?
Yeah, so what eBPF lets us do is to run custom programs in the kernel, and we can load them dynamically, which means we can change the behavior of the kernel dynamically and in custom ways that are specific to exactly what we want to do in our environment. And the really cool thing about being able to instrument the kernel or modify the kernel is it doesn't matter how many processes you're running, it doesn't matter how many containers you're running, whatever you're running on that machine, the kernel is involved and there's one kernel. So if you put eBPF programs into that kernel, it's going to be able to influence and potentially modify behavior across any process that's running. So from a security perspective, malicious processes are just as visible as legit processes. We can see everything that's going on. We don't have to change our applications in any way for them to be visible to eBPF tooling. So it's really very powerful.
Indeed. And you touched on some of the security about, visibility already is, I think, legitimately under the umbrella of security, but also too, just being able to see what are those either containers, user space programs doing. It's a way to set up access control. So I think perhaps there's two paths we can take here. We'll go on a choose your own adventure of creating the eBPF in the first place, but also then applying it to programs or actually having it do something useful that is a security boundary, something to make sure that even that malware can't get on the system, or if it does, it's constrained to a degree. Take your pick.
Yeah, and well, even if we think about networking, there's a security angle there as well, because we can see packets at various points in the network stack, including at the point before they've potentially even hit the CPU. And we can inspect packets, we can modify them, and we can drop them. And there are lots of really useful like network policy use cases for being able to drop packets as well as being able to do cool things like redirect them.
And that's a good point, because one of the things about being able to modify, inspect, deliver packets, that's a great capability for a command and control server, for example. That would be a great use for malware. So what are then, what are some ways that, we look at, I guess, deploying eBPF is where I'm coming down here. How can we make sure that we're using it in a way that have confidence in the security and it's not being abused against us, for that matter, that someone is actually inserting themselves into the kernel and we don't know it?
Yeah. So I think one thing that's probably important to point out is that most people probably won't write their own eBPF programs. Although I've just written a book that will teach you about some basic BPF programming, the reality is it really quite quickly gets into, you're working with Linux data structures. You need to understand the consequences of that. And it is kernel programming, essentially. But there are lots of things that you can do without having too, you don't need to get too in-depth kernel knowledge to be able to get a sense of what you can do with eBPF, which is kind of the approach I took in the book. But I think for most real-life cases, we're probably going to mostly use tools that other people have written, that people who have that kernel knowledge have created. But some of the things that you might want to learn about are the tools that you can use to inspect what BPF programs are running. And what does that mean? I'm very much someone who wants to kind of try things out and feel the code. I don't want to just see boxes and diagrams. I want to actually see it working. So I've tried to give lots of, this is why I kind of got into the level of programming eBPF that I can do, which is really just to understand what's happening and to really see how these pieces fit together. But yeah, so there are tools that you can use to, like one in particular I'm thinking of, BPF tool, that you can use to inspect what programs are running, what maps are data structures that we use in eBPF that we can share between the kernel and user space. And we can use these tools to see what's been loaded into the kernel and get a sense of, are these the programs that we expected? Do these look like they came from the tooling that we think we've installed on that machine? That kind of thing is very important.
I might regret bringing this up, but I'm going to. So one of the things we've been talking about a lot in here last year or two is actually supply chain, and I know you've talked about it too. You just mentioned a lot of the eBPF code that folks are going to be running is actually coming from third parties. Should people start thinking about supply chain and eBPF?
It's actually a really interesting point. So when I mean, first of all, absolutely essential that you get your eBPF code from a trusted source, because an eBPF program could be doing anything. It's like giving out root privileges because it's got access to basically the whole kernel. Yeah. There's some really nice safety features to make sure that eBPF programs don't do unexpected things. They have to go through a verifier as they're loaded into the kernel. And that ensures that it's safe to run in the sense that it's not going to crash the kernel and it's definitely going to run to completion. But of course, if your program was written by somebody malicious, they can do bad things. So you do want to be really careful where your eBPF programs are coming from. And to some extent, that can be controlled by the sort of supply chain security processes that we're seeing being used in user space. If you download Cilium, you're going to download a container image that includes, actually we end up compiling eBPF programs on the fly. And that's quite a common thing to do. But there's also some work in flight in the kernel community to be able to sign the BPF programs themselves. And that's actually more difficult than it is in the case of a normal user space application, because when you have a user space application, here it is, here's the binary, this is you can run a hash over that, the contents of that package or that whatever it is, you can come up with a signature for that executable or that application and all the packages that are coming with it. With BPF, you'd think you might be able to do the same thing. You could take a program, load it into the kernel, have the kernel check the signature. But actually, there are some really interesting things that get done to adjust the program as it's loaded into the kernel to take account of the fact that if I build a program on my machine that's running a certain version of the kernel, data structures might have changed and might be different from the kernel that you're running. So if I send you that program, back in the day, you had to make sure your kernel versions matched because otherwise the data structures wouldn't. Now we have a thing called compile once, run everywhere, which is a super neat approach to portability, but it means that the program that you actually end up running might have been adjusted compared to what I run on my machine. So the signature side of the eBPF program signing is a work in progress because it's a little bit more complicated than you might think.
That is wonderfully complicated. I think that also brings us, let's also bring that aspect in of the book that you wrote. And you touched a little bit that you need, to write a eBPF program, you need to have some Linux kernel knowledge. What about programming language knowledge? We also talk a lot about Rust and other languages. That's one of our favorites. But, can I compile down JavaScript finally and run JavaScript in the Linux kernel? Or what am I stuck with here?
Awesome.
Yeah. So I guess, first of all, we should just make sure everybody's completely on the same page that like the kernel and user space. Because most of the time when if we're writing code, we're writing it to run in user space. But whenever our applications want to do something that involves any kind of hardware, whether that's accessing memory or files or sending and receiving networks, writing something to the screen, all of these things require assistance from the kernel, which is this kind of privileged part of the operating system that can do that. And the user space code makes system calls to the kernel to ask for this assistance. And then the kernel's also coordinating all our different processes that might be running simultaneously. Now, when we write an eBPF program, it gets compiled into bytecode. So there's a set of eBPF instructions in bytecode, looks like machine code, that get compiled. Well, that's what ends up getting loaded into the kernel. And then the kernel actually compiles it to native machine code as well. To get to that bytecode, you could theoretically write that bytecode yourself by hand, but as a human being, not many of us choose to do that. We mostly want a higher level programming language. So it has to be something that can be compiled into that bytecode. And at the moment, the only compilers that support that are, well, the Clang and GCC C compilers and also the Rust compiler. You might think, well, okay, maybe they'll add it to, I don't know, the Go compiler. But in reality, the things like the garbage collection model aren't compatible with the way that eBPF programs work. So you'd end up stripping out so many language features, you'd be back to C anyway. So for the part that you're actually going to run in the kernel, you're pretty much going to write it in either C or Rust. Gotcha. For the user space part that manages it and coordinates with it, you've got a lot more options. There's a variety of different languages that have BPF libraries and relatively straightforward support for interoperating with eBPF programs in the kernel.
Music to the Perl and JavaScript programmers out there. But
Liz, I don't think there's an SDK for either Perl or JavaScript.
I can wish. It's April Fool's weekend, so who knows? But you mentioned too, like the verifier, for example. And when you mentioned that, the verifier is not about the C code or the Rust code that has been written. It's what's been compiled down into this bytecode as well. So it sounds like too that's I think a distinction to make so that we have better insight and confidence that those properties you mentioned. This is going to run determination. We know what it's going to do. Things like that, right?
Yeah, and I think one of the kind of penny dropping moments when you're trying to deal with the eBPF verifier is that it is running over the bytecode. So or when you see an error message, when the verifier rejects something, it's rejecting stuff at the bytecode level, not at the source code. So even if you've got essentially debug kind of bytecode, so you can see what line of source code it is, but you kind of need to understand why it's complaining at the bytecode level, because otherwise the messages are pretty cryptic sometimes.
Yeah, printf debugging is not going to be helpful in that case, I'm going to guess.
Yeah.
Don't worry, I won't make you answer that. You can tell my level of experience here in programming anymore.
I'll foreshadow a little bit to the news and say, hey, maybe you could do something with ChatGPT.
There we go.
Yeah, we have to. I haven't tried this yet. I do need to see whether ChatGPT can write some eBPF code. I'm sure it'll give it a whirl.
Well, so speaking still on this topic of writing the eBPF code for other developers to use it to, whether it's applied in that something performance, or we want the high performance out of it, but to apply in visibility or security, what are some of the principles then that the book covers that you would recommend for someone writing this eBPF so that others can use it, so it's consumable and friendly to others that do live in user space that want to take advantage of it?
Yeah, so in the book, when I start my sort of earliest Hello World examples, use a framework called BCC, which is, I've used Python. I think it's very accessible. You don't have to think too hard about kind of how things are working, and you can get the sense of here is some kernel code and here is some user space code that manipulates it. And BCC is really useful, particularly if you want to do something pretty quickly and if you're familiar with Python. But because of that portability aspect that we talked about before. So the way BCC handles portability is to say, actually, I'm not just going to send you some BPF bytecode. I'm going to send you the source code and I'm going to have you compile it yourself. You've got to have the whole tool chain there to convert the source code to the BPF program. We now have this compile once, run everywhere approach, which is supported by a few different, it requires some user space support as well as compiler support, but there's various different libraries that you can use to do that. So if you're going to go out tomorrow and write a production, quality, commercial, or open source project, but that you want thousands of people to use, you probably want to use one of those compile once, run everywhere SDKs and languages to enable other people to run it on their version of the kernel.
BCC is a great reference, good open source example of just understanding how it's used, how it's built. What are some other open source tools that you would point people to either help with development, debugging, for example, or just examples of good eBPF-based tools that would be great to use within container space or the, just general Linux system administration?
I think for people who are getting their hands pretty dirty and actually playing with BPF programs, then BPF tool is a really great command line tool for seeing what's installed, inspecting the different programs and maps and all the other different aspects of what's in your kernel at the moment. So BPF tool is really quite powerful. The BCC project comes with a whole load of tracing tools. A lot of them were the things that Brendan Gregg was originally popularizing around observability and giving you that insight into how your system's performing. And there's a whole host of those, pretty much any aspect of your system. There's a CLI tool that's part of BCC to do this. Most of those have now got their compile once, run everywhere equivalents, so you can install those, and there is a package that you can install, so you don't have to worry about that. Where they came from. Here you go. Here's a family of really great tools that you can use, and then we start getting into the more kind of broad, I guess, more capable, more in-depth projects. So things like Cilium, which is a networking platform primarily for Kubernetes, but also for connecting to external workloads as well, and doing things like network security alongside. Projects like Falco or Tracy that comes from Aqua Security, or the new Cilium Tetragon project, which all of them are looking at runtime security and using eBPF to compare behavior against security profiles. Is this behavior that we're seeing out of line? Does it potentially represent malicious activity? I think one of the really cool things that is happening in Tetragon is you're not just sort of finding events and sending them to user space and then having user space say, oh, okay, that's a file open event. Do I think that file should be opened? With Tetragon, we can actually do the filtering in kernel, so you can have the policy understood within the kernel, a bit like network policy drops packets within the kernel, which I quite like that analogy, that you can really affect the behavior inside the kernel rather than having to wait for some user space filtering to take place.
Yeah, and that's what seems really compelling about how you describe this, is that not only compile once, run anywhere, but you also have a central management of a central deployment spot too for the security visibility. You don't have to adjust every single container for this, right? Or you don't have to install this within every single container, so that then you can also see, as you mentioned, why is a file open happening? Why is a file read happening for a system that's just doing some stateless data manipulation of a JSON blob? So that seems really compelling. That's like, we should both block it as well as know what's going on, because that seems like something hinky is there, something not good.
Yeah, definitely. And I think the future of, I think there's a large amount of sort of undeveloped security practices where we will have these profiles that are easy to understand, that you can relate against applications, and you can say things like, should this application be sending network messages, and if so, to whom, or which files should it be opening, and some pretty easy default behaviors that you can think, like how many of your processes should be accessing files in the etc directory, those kind of policies that I think we will increasingly see being enforced at runtime, because we'll have a lot of the runtime behavior tools that we've had, or IDSs, I would say the profile or the way that you can express policy is really low level. Things like SE Linux, where it's really complicated to write an SE Linux profile. And, I think in, a few years' time, we'll all be writing security policies that kind of go alongside applications that just kind of say, well, this program should do this, that, and that's kind of it. A bit like in the old days, you used to say, yeah, my application needs port 774 or whatever it was you wanted to ask to be opened. I think you'll ask for the kinds of runtime permissions that you want. That's my crystal ball for how security is going to
Liz,
work.
you touched on something interesting there. At least I think I think you hit this in your previous life too. I know I did it in mine. When you're gathering that much data off these runtime processes, the data has to go somewhere. Talk a little bit about like either the volume of data or what are people. I mean, it's really a fire hose that you're pointing at someone like, here's, all the debug data off like all these processes running in your cluster. Are people able to deal with that, or are they getting value out of it? I don't mean this in it sounds sort of negative the way I'm describing it, but like there's so much there. How do you deal with it? I guess is what I'm trying to suggest or ask.
Yeah.
eBPF.
And I think you're absolutely right. You can end up with, if you have a very undiscriminating set of, let's see all of the events, you end up with, first of all, the collection of those events being, resource heavy and processor heavy. And also then you've got a ton of data, and can you get that data out quickly enough? Can you look at it and can you make any sense of it? And I think that's where, again, eBPF based tools can really help with both of those aspects. So partly just the speed of eBPF. One of the really cool things about it is you don't have to go, here's an event, transition to user space, write it to a file or send it somewhere, and then transition back. You can write it directly into this structure called a map, which is done inside the kernel, no need to transition. And then asynchronously at some other point, user space can get hold of these events. So that's a pretty efficient mechanism. But also, you can do this in kernel filtering. So you don't necessarily send every single file open event. You'll say, I'm only going to tell you about things that don't match a policy, some kind of profile. And the other thing that is really cool that we've been doing in Tetragon is the relationship between not just this event happened, but what was the executable that was running at the time? What was the process ID? What's the process hierarchy? What containers it running in? And in a cloud native environment, knowing what was the pod, what was the node, what was the namespace, all of these kind of forensic material. And you've got all this sort of timestamps, so you can see, this suspicious looking file open or this suspicious looking network connection can actually be traced back to this process that was started in this pod 3 days ago, and, figuring out how that compromised pod came to be compromised becomes a lot easier.
And that's a good point that John brings up. What are some you have a book, you've described a little bit of just the expectations of building an eBPF program, a filter to do something positive for beneficial for security. For the end user now that wants to deploy that, adopt that, what are other things that users should think about, consider for deploying, adopting like configuration, volume of data?
Yeah. I'm actually going to start with a positive benefit. And one of them is that you can load eBPF programs into your kernel without it having to affect or disrupt pre-existing processes. Like they will be, a process that's already running. If you're looking at file open events, you'll start seeing those file open events. You don't need to restart your processes. You don't need to restart there's a really great scenario called, about mitigating packet of death vulnerabilities. So if you imagine you've got a vulnerable kernel that you can send it some particularly crafted network packet and it hits a vulnerability in the kernel and that would crash the machine and everybody would have a bad day. And if that involves a kernel patch, then, you've got to install the kernel patch and you're going to be rebooting the machine and you've got to figure out how to roll that out across however big your deployment is.
That'd be great for forensics too, real quick.
Sorry?
That'd be great for forensics as well also, but keep going.
Yes. And you can just download or install an eBPF program with a mitigation to, find those particularly crafted packets and drop them. And your machines are protected from that vulnerability and you didn't have to restart anything, which I think is a wonderful facet of the way that eBPF works. And the fact that you can change things very dynamically and change what you do or don't have running. And eBPF dynamically. I think that's a huge bonus.
Yeah, so indeed, very user friendly. Part of that too, you mentioned too, like SE Linux, which is not the easiest thing to configure, especially if you want to say, imagine we mentioned supply chain. Let's throw in an SBOM here, that where an application says, "Here's my SBOM that includes the SE Linux configuration. These are all the syscalls I need to access." How does this look like in eBPF world? Does this make things easier? How can I figure out how to narrow down that I just want this particular user space program to have these few syscalls, but to continue running and not crash at unexpected times?
So actually, one of the uses that a lot of people will have already made of eBPF is setcomp, or rather BPF. So setcomp has been implemented using that kind of BPF virtual machine. So some relatively straightforward rules, but that are used to enforce those setcomp rules about what syscalls can run or can't. eBPF allows us more flexibility, things like the ability to look at the parameters that are passed to. I mean, if you pass, let's say, a file name into a syscall, it's probably actually a pointer, and if you can't dereference that pointer, it may not be that useful. But with eBPF, we have a lot more ability to look at the memory that is pointing to. So that's an evolution of what you were able to do with setcomp, even setcomp BPF. There are lots of tools, lots of sort of security-based tools that have taken that syscall approach, but it's not a particularly. It's fine up to a point, but there is a top to time of check to time of use gap between looking at the parameters as they're being passed into the syscall, and then as the kernel starts processing that syscall, it's going to copy that into kernel memory and start building data structures to represent whatever it is that you're acting on. And there is a potential window between looking at what was passed in user space and it actually being copied into kernel memory. And the kernel documentation, if you look up the sort of syscall interface, you'll find documentation in there that basically says this is not a security interface. Don't use this for security. So instead, there is a stable interface called the Linux Security Module API that's inside the kernel. Those attachment points are typically after the kernel's built its data structure. So, here's a file that I'm about to act on, and you're looking at the data structure that is genuinely what the kernel will look at. And you can attach eBPF programs into that interface as well, into that LSM interface. So it gives us the ability to build things like SE Linux use that interface, but they have this very kind of it's kind of cast in stone how you can write those profiles. Whereas if we can attach any custom eBPF program, it allows for a lot of flexibility in how we might write tooling in the future and how we might make it a bit more custom, a bit more bespoke, a bit more user-friendly, a lot more user-friendly.
A lot more. And honestly, making something user-friendly sounds like a wonderful tenet to have for a security feature, for something for adoptability. And you mentioned early on that there's more adoptability now because kernel support now is more universal. It's much easier. So looking ahead too, you've seen, and you've like you said, like seeing the adoption now. Looking forward, another 6 months, perhaps another year, or just in some handwave future, what's something you'd like to see, or where's the more of this positive direction you'd like to see eBPF going?
Yeah, I would definitely like to see. And this is really more on the user space side, but the ability to craft profiles in a way that normal humans and normal developers and normal security people can understand. So I think that will be a big step forward. And we're also going to see, I think, just a huge range of tools that I haven't even thought of. There's so so many different parts of the kernel that can be instrumented and people can do exciting things with. I think there's going to be a proliferation of ideas that are based on how we can improve the kernel, enhance the kernel, allow you to customize the kernel in particular. So an example, the kind of thing I'm thinking about in Cilium, we're using eBPF to bypass parts of the networking stack for performance reasons. Essentially, we don't necessarily need to use all of it, so we can pass it, and particularly bypass IP tables. And that can lead to some huge performance improvements. There must be other sort of similar parallels that you can draw in other areas of the way that a system operates that, are potential areas that eBPF could tackle in the future.
Those are cool. We definitely don't want people to bypass your book or the work that you've done in the past. So I'm curious too. Well, where you've been quite involved in a lot of the conferences from the CNCF. Where's something that you would love to draw people's attention to your book, of course, or some other presentations or conferences that you're even excited about over the next couple of months?
Well, yeah, coming up just in the next couple of weeks, we are 2 weeks away now from KubeCon as we're recording this. We're going to have the first ever Cilium Con, which is going to be a co-located event on the Tuesday. So anybody who's in Amsterdam and interested in Cilium and eBPF, Cilium Con is the place to be. And, we're going to have people there who are involved in implementing eBPF in the kernel. So there's going to be a lot of really great expertise. We're going to have people talking about their use cases at scale and how they've been adopting eBPF and Cilium in particular. So really, really excited about Cilium Con. And then later in the week, the whole KubeCon, I've got a talk and a panel that I'm going to be taking part in. And I will also be doing some book signings. So keep your eye out on the iSurveillance stand for when we do those book signings.
Wonderful. No, that'd be a great way to see some more of your work and hear more of your thoughts. I do have one final thing that we'd love to get your thoughts on, but I think it's pretty easy. We always ask our guests to describe AppSec in 3 words. So what 3 words would you give us, Liz?
Yeah. So I don't know if it's a secret, but that, you give your guests a heads up that this question is coming. And I could not get out of my head defense in depth. I don't think it's very original, but I just think it's super important. Defense in depth. I couldn't get past that.
I think it's considering eBPF goes in depth into the kernel, we can understand why this is also on your mind. And I think you actually might be the first one to give us that response. So,
really? Okay.
It's a good reminder. Yeah. So thank you for that. But more importantly, thank you for giving us a look into eBPF, verifiers, bytecode, and no worries about the Perl and JavaScript lack of SDK. We'll ask you about that the next time you're on.
Absolutely my pleasure. Thanks so much for having me.
Thank you so much, Liz. Thank you to John. Thank you to all of our listeners. We'll take a quick break and return with news of the week.